All right, now that we've talked about how to graph inequalities in one variable using a number line, let's take a look at solving inequalities. So we want to start with taking a look at some of the rules that we have to follow when we're solving inequalities in one variable. So first, and probably the most important rule, because it's different than solving equations, is that when you solve an inequality, when you're doing that, if you multiply or divide by a negative number on both sides, then you must reverse the inequality symbol. And number two, we always want to write our answer with the variable on the left. So if you solve the inequality and the variable is on the right-hand side, all we want to do is reverse everything and write the variable on the left-hand side. The reason why we do that is it makes it easier to think about the solutions using a number line. And then our third inequality rule to follow is that we pretty much solve it like an equation. All right. So we solve inequalities like equations where we have a balance point at the inequality symbol, left side versus right side. And rule number one, we just have to watch out for that. So I want to go through an example showing you why those rule number one must be followed. So here we have just a table where I want you to focus on what's happening up here in the top right-hand corner. Right now, we just have an inequality statement with numbers where we can easily compare and see that that is true, that 10 is less than 20, all right? So it's a true statement. Now, if we were to divide both of those numbers by 2, okay, if we take 10 and divide it by 2, we're going to get 5. And if we take 20 and divide it by 2, we're going to get 4. Now, looking at our inequality, 20 divided by 2 is 10. Looking at our inequality symbol, we're comparing these two numbers, 5 and 10. And we would say that, well, 5 is less than 10. Okay, 10 is the bigger number, so the alligator's mouth is open towards that number. From left to right, though, we can read it as 5 is less than 10. All right. Next, we're going to subtract 3 from each of these numbers. So if we take 5 and subtract 3, that will give us 2. And if we take 10 and subtract 3, that'll give us 7. And then choosing the inequality symbol that completes this statement. From left to right, we wanted to read that 2 is less than 7. So we use another less than symbol. You see how all we've done so far is we divided by 2, we subtracted by 3 on both sides of the inequality, and the inequality symbol has stayed the same. Let's continue. Multiply by negative 4. So if we take 2 and multiply it by negative 4, we will get negative 8. If we take 7, multiply it by negative 4, 7 times negative 4 is negative 28. Now think about these two numbers. On a number line, we would see that negative 28 is further to the left and negative 8 is further to the right on a number line. So this actually means that negative 8 is bigger than negative 28. Look what happened. Our inequality symbol went from less than, less than, less than, and now all of a sudden it changed to be greater than. I'm going to mark this to remind me as to that's the one that caused the inequality to flip. We multiplied both sides of the inequality by negative 4, and it changed which side had the larger value. Let's continue. Let's add negative 12 to both of these numbers. So if I take negative 8 and add negative 12, I will get negative 20. If I take negative 28, add negative 12, I'll get negative 40. When comparing these numbers, because negative 40 is more negative, it is actually a smaller number. So we'd use the greater than symbol to complete the statement. Negative 20 is greater than negative 40. Okay, so my greater than symbol continued to be a greater than symbol. No change there. Next, we're going to divide by negative 10. So we're going to take the numbers in the previous inequality statement and divide each number by negative 10. Negative 20 divided by negative 10 is 2. Negative 40 divided by negative 10 is positive 4. And when we compare these numbers, we see that 4 is bigger, 2 is smaller. So we would use the less than symbol to complete the statement. 2 is less than 4. Notice we had greater than symbol before. Now it changed back to a less than symbol. I'm going to mark this one again. Next, we're going to multiply by 3. So 2 multiplied by 3 is 6. And 4 multiplied by 3 is 12. Comparing those numbers, we can see that 6 is less than 12. So no change in the inequality symbol in that step. Last, we need to add 8 to both sides of the inequality. So 6 plus 8 is 14, and 12 plus 8 is 20. Comparing those two numbers, 14 is smaller, so that we would read from left to right. 14 is less than 20, and the inequality symbol stayed the same. So the only time where our inequality symbols flipped or reversed is when we multiply both sides by a negative number and when we divided both sides by a negative number. That's what's going to cause the inequality to actually have the larger value on the opposite side. It's going to change it completely. But notice when we added, whether it was a positive or a negative, it didn't change the inequality symbol. When we subtracted, it doesn't change the inequality symbol. When we multiplied or divided by a positive number, it did not change the inequality symbol. The only times the inequality symbol reversed or changed is when you multiply or divide both sides of the inequality by a negative number. All right, so that's what rule number 1 is really describing, is that relationship. Now, it's important that we remember this because when we solve inequalities, like this example here, we may end up dividing both sides by a negative number when we're solving. And because x is involved, we're not necessarily going to see which side is bigger anymore. We're not going to be able to just compare two numbers because we have a variable instead to compare it to. So we have to remember that rule of what happens when you multiply or divide both sides by a negative. So in this case, I'm going to draw my train tracks around the inequality symbol because that represents kind of the middle of my inequality sentence. And if I'm solving the inequality, it means to get x by itself. I want to figure out what values for x would make this true. So I'm going to undo multiplication the same way we would solve equations. So I'm going to divide by negative 3 on each side. That's going to leave me with an x on the left, and it's going to leave me with negative 6 on the right. However, here we have that rule where we divided both sides by a negative number. So I have to take this inequality symbol, which was greater than, and I have to reverse it to be less than. Okay, so again, I've reversed the inequality symbol because I divided both sides by a negative number, a negative 3. And what that does is it changes which side is bigger. So now it's x is less than negative 6. So when I graph the solutions, you'll notice my number line isn't numbered. So what I want you to do is solve first to get your boundary value. We can see my boundary value is negative 6. Now on the number line, if you think about where negative 6 is, it's not going to be to the right where we have our bigger numbers. It's going to be to the left. So negative 6, I think that's my 6th mark, would be there. So think about what number is to the left and to the right of negative 6. Keep in mind you're on the negative side. So it's going to be negative 5 on its right and negative 7 on its left. Now I go back to my inequality symbol to help remind me what type of circle I draw at negative 6. Since it's not the equal to inequality, I want to make sure that I leave it as an open circle. The open circle represents that negative 6 is not a solution. And everything that's less than negative 6 goes to the left. So we have our solution and our graph. All right, here's number 2. We'll go a little bit faster through this one. We have our inequality symbol, which gives us that balance point. To get x by itself, I'm going to subtract 4 on both sides, and that's going to leave me with an x on the left and a negative 15 on the right when I combine negative 11 and negative 4. And all I did was subtract, so the inequality symbol is going to stay the same. So there's my solution. It's that all the x values that are less than or equal to negative 15 would solve that inequality. So I go to my graph. I start with negative 15 in the middle. I know that on the negative side of the number line, that means that it's a less negative number to its right and a more negative number to its left. My inequality symbol is less than or equal to. So negative 15 in this case is actually a solution to that inequality because negative 15 is equal to negative 15. So I fill in my circle, and then I want to shade the less than side. So I want to shade to the left. That's where all the other numbers are that are less than negative 15. All right, number 3. Negative 13 plus m is less than or equal to negative 5. Let's see, to get m by itself, I have to try to get this negative 13 on the other side. I have to try to zero it out. Because it's a negative number, I'm going to have to actually add 13 on both sides. Negative 13 plus 13 is 0. 0 plus m is m. negative 5 plus 13 is positive 8. And I can bring my inequality symbol down because I didn't multiply or divide by a negative number when I solved. All I did was added 13 on both sides, and that's never going to change which side is bigger. So I have m is less than or equal to 8. I'm on the positive side of the number line now, so it's just going to go in order, least to greatest from left to right, 7, 8, 9. I want to show that 8 is a solution because my inequality symbol has the line under it. And anything that's, let's see, m is less than the 8 is going to be to its left. So I draw my arrow to the left. Number 4, we have negative c over 4 is greater than 8. Now, it looks like that, the way that it's written, but what I want you to do is I want you to visualize it as c divided by negative 4. So put that negative with the 4 in the denominator when we solve something like this. Now we're trying to undo this division, this fraction bar. So we're going to multiply by negative 4 on both sides. And when we do that, we're going to just get c on the left. 8 times negative 4 is negative 32 on the right. And notice what we did here. To solve this, we multiplied both sides by a negative number. And as we saw earlier, that means the side that's bigger is going to change. So instead of having a greater than symbol, it's actually going to reverse the other way and become less than. So our final solution, our values for c are less than negative 32. So on my number line, I'm going to put negative 32 as my boundary. Knowing I'm on the negative side of 0 and how that works on the number line, it would actually look like that. And I want to use an open circle because it's strictly less than negative 32, but not equal to negative 32. And then anything less than negative 32 will be to the left on the number line. So we had to reverse the inequality symbol because we multiplied both sides by negative 4 when solving. All right, last one. Number 5, we have 5p is greater than or equal to negative 20. It's kind of like the first one. We just have multiplication happening here. So we want to divide by 5 on both sides to solve this inequality. 5 divided by 5 is 1. So that's going to leave us with just 1 times p, or p. Negative 20 divided by 5 is negative 4. Now, we did divide on both sides of the inequality. We divided by 5, but that's a positive 5. Okay, we didn't divide both sides by a negative number, so I do not reverse the inequality symbol. I leave it as greater than or equal to. So on my number line, negative 4 is my target value. I'm on the left side of 0, so I know that it would go negative 3 on the right and negative 5 to its left. And because it's p is greater than or equal to negative 4, I want to make sure that I show that negative 4 is a solution by filling in the circle. And the numbers that are greater than -4 this time will be on the right side. All right, so we have our solution and the graph of the solutions.